So here we have an example. So in a college graduating class, a study shows that 60% of the class are brunettes, 20% have green eyes, and 5% are brunettes and have green eyes. So what is the probability that a randomly selected student from this graduating class will have brunette hair or green eyes? So one of the things to really watch out for this is there's the word or. So we were looking for everyone who has either brunette hair or green eyes. So if you remember, the addition rule says that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so let's try to figure out what these percentages actually represent, because what we're basically looking for is the probability. Let me change the color. So we're looking for the probability of those that have brunette hair. So let me say B is going to stand for brunette, and G is going to stand for green eyes. Okay, so we're looking for the probability of B or green eyes is equal to the probability of being brunette plus the probability of having green eyes minus the probability of brunette and green eyes. Okay, so this is what we're looking for. Now let's try to figure out what the probability of being brunette is. So the probability of being brunette is just 60%. So 60% of the class are brunettes. So this is going to be 0.6. Okay, because remember, probability can only be between 0 and 1. The probability of having green eyes, 20% have green eyes. Okay, so that's going to be 0.2 right here. Right? Then minus the probability of being brunette and having green eyes. This is this 5%. So as a decimal, this will be 0.05. So I add the 0.6 plus the 0.8. I'm sorry, 0.6 plus 0.2 minus 0.05. That's going to give me 0.75. Okay, so this is a probability. Okay, so this is a really good problem. It has all the information that we need. All we have to do is plug it into the formula. All right, so in number 2, we have a company must choose among 3 different health insurance plans and decided to ask their employees about the preference. So below are the results. So this is assuming that the workers cannot choose multiple plans. They only have to choose one. So when I give you a contingency table like this, even before you do some problems, what I would advise is to complete the margins. So what I mean is add up all these numbers together. That way you have some sort of margins here. So 160 plus 140 plus 40. So I'm going to add all these numbers together. 160 plus 140 plus 40. That's going to give me 340. Then I'm going to add this row of hourly workers. That's going to be 40 plus 60 plus 60, which is going to give me 160. Then I'm going to add everyone who chose plan 1. That's going to be a total of 200 people. Everyone who chose plan 2, this is another 200. Everyone who chose plan 3, that's going to be 100. Okay, so this is good because it tells you how many people chose plan 1, regardless of whether they're salaried or hourly, and this is 200. And then the rows tell you, of the salaried workers, or how many salaried workers do we have? That's 340. Now, adding all of these numbers up, adding up 340 plus 160 and then 200 and 200 and 100 will give me 500. So this is how many total employees I have, okay, regardless of the preference of the plan. Okay, so what I have now, we want to figure out what is the probability of randomly selecting a salaried worker and someone who is in favor of plan 2. Okay, so we want to figure out the probability of being a salaried worker and someone who is in favor of plan 2. Okay, so all of those probabilities will be here. So a salaried worker, so here are all of my salaried workers. All of this row will represent all of my salaried workers. Now, of those people who are salaried workers, why we are looking for, you are a salaried worker and you have someone who is in favor of plan 2. So we have 100 people who are salaried workers and are in favor for plan 2. So probability of salaried and plan 2 is going to be equal to 140 out of the total 500. Okay. So watch out for those things. So remember, and or are always out of the total. Okay. We are always basing that off the total. Okay. We're not restricting anything. Okay. What is the probability of randomly selecting someone who is in favor of plan 3? Okay, so we're just looking for people who are just in favor of plan 3. We don't care if they're salaried or hourly. In this case, people who are in favor of plan 3 is just going to be this 100, because all of these 100 people are in favor of this plan 3. So this will be 100 out of 500. This is going to be the probability of those that are in favor for plan 3. Okay, you can reduce if you want to, or you can just leave it like this. All right. Then what is the probability of randomly selecting an hourly worker or someone who is in favor of plan 1? So remember, here we now have the or, so we're going to have to use the addition rule. So the probability of selecting someone who is hourly or someone who's in favor of plan 1 is going to be equal to the probability of hourly plus probability of 1 minus probability of hourly and 1. Okay, so the probability of selecting someone who's hourly, so I don't care what plan they chose, I just want to look at the hourly workers. That seems to be 160. So this one over here is going to be 160 over 500 plus the probability of just selecting plan 1. So 200 people selected plan 1. Okay, so that's going to be 200 out of 500. Okay, so here, probability of hourly and 1. So we're looking at those who are hourly and have chose plan 1. We're not multiplying things together here. So that's one of the biggest mistakes, to don't multiply anything, because it's literally here. Hourly and plan 1 is literally right there. Those are hourly and plan 1. That's 40 out of 500. Okay, so now let me go to my calculator. So 160 plus 200 minus 40 is going to give me 320. So it's going to be 320 over 500. Okay, and that is my final answer. Okay, so now we have part D. If a randomly selected worker chose plan 3, what is the probability that they are an hourly worker? So here the key word is if. So if they chose plan B, so the probability of, given that they chose plan 3, what is the probability that they are an hourly worker? Okay, so this is a conditional probability. So we already know that they chose plan 3. So if I know they chose plan 3, how many people selected plan 3? Well, 100. Out of these 100 who chose plan 3, what is the probability that they are an hourly worker? Well, that's 60, because 60 workers chose plan 3. So this is going to be a 60 out of 100. So notice that here, this 100 represents the restricting of the domain. So here there's a restriction because it's under the condition that the worker chose plan 3, okay, where the other problems did not have that. And then part E is being salaried and choosing plan 2 a disjoint event. So if you remember, disjoint event means that these two events cannot happen at the same time, cannot occur at the same time. So here, can you have someone who is salaried and someone who choosing plan 2? And the answer is yes, because you have 140 people who are salaried and chose plan 2. So this one is not a disjoint event. Okay, because you can select 2. You can select both. Both at the same time. Okay. All right. So in the next video, I will go ahead and go over some questions for the multiplication rule.